Example 6.1. So this is about a store in KL, and they want to determine the optimal order size and also the total inventory cost for a brand of carpet. And they also give you this information where the annual demand for this type of carpet is 10,000. Okay, so normally we use D for the demand. So D equals to 10,000. And the annual carrying cost is 0.75. Okay, so carrying cost, you can use CC or CH, it's up to you. So CH is actually for the holding cost. Okay, this is 0.75. And the ordering cost is 150. So the ordering cost is 150. And now the store also wants to know the number of order, okay, that will be made annually, and also the time between orders. And now we know that the store open 311 days annually. Now, optimal order size is actually the EOQ, economic order quantity. So we can use the formula here. Okay, the formula is square root of 2 times the ordering cost times the annual demand and divided by the holding cost. Okay, so just substitute all this information, okay, into the formula. So 2 times the ordering cost is 150. The annual demand is 10,000. And the holding cost is 0.75. Okay. Here we have 2,000. So now we know that our optimal order size or EOQ is 2,000. Okay, so every time we put an order or we place an order, we have to order 2,000 yet, so that it will optimize our order size. Now for total inventory cost, we have the formula. Okay, so total cost, the optimal total cost is the ordering cost times D, or the annual demand, divided by Q optimal, okay, plus the holding cost times Q optimal divided by 2. Okay, so this is actually the average holding cost. Okay, so just substitute all the information. So in this case, we have 150 times annual demand is 10,000 divided by 2,000. So 2,000 is actually the one that we have calculated earlier. Okay, this Q optimal is actually our EOQ, because EOQ is, now we know that every time we order, we should order 2,000. Okay, so our Q optimal is 2,000. Okay, and plus the holding cost, which is 0.75 times Q optimal 2,000 divided by 2. So we have so now our total cost will be 1,500. Okay, next, the company also wants to know the number of orders per year. So the number of orders per year, so it depends on what is your annual demand and also what is your Q optimal or your order size. Okay, so in this case, annual demand divided by Q optimal. So annual demand here is 10,000 divided by your Q optimal, or your ordering size is 2,000 yard. So in this case, in 1 year, you will order 5 orders. Okay, so there will be 5 orders per year, and every time you order, you will order 2,000 yard. Okay, because this 2,000 is our Q optimal, or our economic order quantity, or our order size. Okay, and then next one, the company also wants to know the order cycle time. So the order cycle time is so in 1 year, so what is the gap between each order? Okay, so in 1 year we have 311 days, and every time and also in 1 year we have 5 orders. Okay, so from our previous number of orders per year. Okay, so in this case, the order cycle time is 62.2. Okay, example 6.4 is actually a continuation from example 6.1. Okay, it's about a store, a carpet store. Okay, so and then they give you the previous information where the annual demand is 10,000. The ordering cost is 150 per order. Okay, the holding cost is 0.75 per unit per year, and the shop open 311 days per year. Okay, so now this example is about the non-instantaneous receive. Okay, so basically this type of example can refer to a company where they have their own manufacturing facility. Okay, so in this case, we assume that this store has their own manufacturing facilities where they produce their own carpet. Okay, so now instead of having to order the carpet, we assume that the ordering cost is the setup cost. Okay, because when we want to produce something, okay, so we have to set up the machine. So in this case, the setup cost, okay, is from our ordering cost. Okay, and every time they set up the machine, okay, set up the production, so they will receive 150 yards of carpet. Okay, so that's why this example is about non-instantaneous receipt. Okay, now we want to find the EOQ. Okay, so, and then the number of days it takes to receive an order completely. Okay, the number of orders per year, the maximum inventory level, and also the minimum total inventory cost. Okay, and because this is about non-instantaneous receive, so basically we must have the value of D and also the value of P. Okay, so D is actually our daily demand rate, or the demand rate per day, and P is actually our production rate. Okay, let me put here. Okay, the demand rate per day, or the daily demand rate, and the production rate per day, or daily production rate. So in this case, okay, so for the demand rate, so we just have to take the annual demand. Annual demand is 10,000. Okay, and the shop operate 311 days per year. Okay, because we want to know the demand rate per year, per day. So take the annual demand divided by how many days the store operates per year. So 10,000 divided by 311, we have around 32.2 yards per day. Okay. And for the production rate, okay, so just okay, and for the production rate, okay, production rate, this one come from this one. Okay, so every time you set up the machine and produce, okay, your carpet, so it will be 150 yard per day. Okay, so D or demand rate equals to 32.2 and the production rate equals to 150. Okay, now to answer the question, okay, so the first one they want to know what is EOQ. Okay, so EOQ or economic order quantity or Q optimal. Okay, so since this is example for non-instantaneous receive, so basically the formula is slightly different. Okay, so Q optimal or EOQ, okay, basically these are the same. Okay, is okay 2 times the ordering cost times the demand, annual demand, divided by the holding cost times 1 minus D over P. Okay, substitute all the information into the formula. Okay, so we have 2 times the ordering cost is 150. Okay, remember ordering cost here is the setup cost. Okay, and the annual demand is 10,000. Okay, divided by the holding costs times 1 minus D over P. Okay, so we have 2256.8. Yeah. Okay, for the second question, they want to know the number of days to receive the order completely. So when we are dealing with the manufacturing operation, okay, this is also called as the length of the production run. Okay, okay, just put okay the production run. Okay, the length of production run. Okay. Okay, number of days to receive orders completely. Because every time you put an order, okay, you only receive 150 per day. So in this case, the production run is equals to the Q optimal, which is 2256.85 divided by 150. Because every time you do the production, okay, you set up the production and do the production, okay, the cost, the quantity or the Q optimal is 2256.85, okay, and you only receive 150 per day. So basically the line is Q optimal divided by 150. Okay, 15.15 days.